Welcome back. Welcome to the second session in Object-Oriented Programming Fundamentals. In the first section, we talked about the difference between procedural language and object-oriented language. We talked about C program, how it works in procedural, and then how it worked in a Java program in terms of object-oriented language. We talked about classes and objects at length. We talked about some of the features of object-oriented programming. We looked at how the this variable works, how references work in Java. These are some of the fundamentals that we saw. In this section again, we are going to talk about encapsulation. The main thing that's going to be different from the other channels that you would have already seen is, in this channel, we are going to look at a C program. We will show you the disadvantage in C, and then we will get into Java. We'll again go hands-on in Java and show you how encapsulation is going to support the entire thing, and this will continue for all the different OOPS paradigms that we will see. So first is we'll start with encapsulation, right? Before that, in the OOPS concept overall, right, why do we have to go for OOPS? Last section we talked about it, but quickly a recap of it, right? OOPS mimics real world entities. OOPS enables data security. OOPS helps in reuse, right? Your code reuse is enabled in OOPS. OOPS hides complex implementations from the end user, right? Whoever is going to be the consumer of a particular class will not need to know the details of implementation. And OOPS makes the code scalable. These are some of the very prominent features of OOPS. Now, when we say it mimics the real world entity, when we say it is data security, let's look at which of these features of OOPS enabling each of these, right? So when we say mimics real world entities, it is actually an object or class. We looked at it in the last section as to how the object or class is mimicking a real world entity. Data security is enabled by encapsulation. Our entire video now is going to focus on this. Reuse is polymorphism, where change of behavior also can be witnessed. Hiding complex implementation, right? So that's going to be abstraction. And finally, maintaining the hierarchy from one class, parent and child relationship, scaling the class, all this comes with inheritance. Now, these are the features that we will see, right? First, we will start with encapsulation. Then we will jump into the second, polymorphism. After that, abstraction, and then inheritance. We will look at each of these features in greater detail in this particular thing. So first, encapsulation, right? Let's get into that. We will see what is encapsulation, what is the unique feature in encapsulation. So encapsulation, when you look at it, it's a feature. This is the first feature we always have to look at when we consider object-oriented programming, right? Encapsulation is the fundamental OOPS paradigm. After you understand encapsulation, you can go into the details of the other features of OOPS. What is encapsulation? By definition, encapsulation is a process by which data and variables, basically the state, right, and the code that acts upon the data, the methods, are integrated into a single unit. This is the textbook definition. But the problem here is, this is what we said is a class. Yesterday when we looked at class, we said class is nothing but it has both data and method joined together, right? Then the same thing is being again repeated for encapsulation. So we need to dive deeper to understand this better. So is this definition wrong? Actually, no. Encapsulation, yes, it combines variables and methods together. Again, we saw class again means the same. But here it's something more extra, right? It protects the methods and variables. That's going to be the most important part. It is not just putting them together, right? In a class, when we define the class, we said class means it has variables, which is the state, and methods. Encapsulation protects the data and methods from unauthorized access and modification. It is not just putting them together. Here, the crux of it is, it prevents unauthorized access and modification. Only the valid users will be able to touch it. Unauthorized users cannot touch it, right? So that's going to be the most critical part. In this video, we will see that in greater detail. And first is, we'll see what is missing in a C program, right? How is this Java enabling it? So first we have to understand what is missing in a C program. So let's look at a C program. Again, we'll take a student record here. a student structure, right, which has a name and an age. And the valid values for the age, let's assume it is 1 to 100. These are the valid values that you can have for the age field. Now in a C program, if you see, I am declaring a variable of the struct student named S, and I'm directly setting that value to 300 and I'm printing that value, right? So when I run this program, I'll get an answer saying 300. And C does not check anywhere because I've not written any code here to say that the value has to be between this to this, right? I have not said it has to be between 1 to 100. I have not done any check. So what C does is it allows you to set any value, and you can set the value, you can modify the value. And the struct student, if you look at it, there is no way you can say within the structure that the value has to be between 1 to 100, right? So now what happens in a C program is, we know that there are many programmers who are going to write many functions. In a normal C program, there will be many functions that will be written by different programmers. And each programmer will use the variable and modify the values within this variable. And he or she can set any value to that variable. So the disadvantage in C is, you cannot in a structure say in any way that this age can take a value between 1 to 100. Any other value cannot be set to this variable. So typically whenever you use a C program, you would have seen that wherever a variable is being consumed, at that time there will be a check done. Is the value less than 0? Is the value greater than 100? If so, throw an error. Every time you use the value, you will have to check and enable that. This is the big pain point in C. Now let's look at Java. I'm again doing a class student here. I have the name, I have an age. We'll talk about private in a bit. Private means you cannot use this variable in any other class. Here in this program, I have two classes. One is student, one is the main class. But here what I'm saying is, there is a student and there is a constructor for the student. It is a parameterized constructor which takes the name and number, and I'm initializing the state variables using that parameterized constructor. Then I have two methods I've written, right? One is called set age and there is one more called get age. These are the two things which are going to enable encapsulation. The set age is called as the setter method. Get age is called as the getter method. Now how do these help, right? What is really going to work here? So when you look at it, we have defined it as private. Private means this variable name and age can be modified only by the methods within this particular class. Other methods in the main program or any other class cannot touch this value. So I have defined, I have instantiated an object, right? S1, where I am saying Satish and 50. Now, if I try to set the age, right, s1.age equal to 100. If I try to access that particular variable, you will see that it will throw an error, right? This is one level of data protection Java is providing you. So it is saying that you cannot, any other class cannot modify the value directly. So that age field cannot be modified as long as it's declared as a private. So now private is called as an access modifier. We'll talk about it in a bit. As of now, whenever I say it's a private int, it means it can be accessed only within this class. Any other class cannot touch this particular variable. Now in a setter method, how it helps is, so here you have set age. So if you look at it, it's a public method, right? So public means any other class can access it. So not just within the student class, even from the main class, you can access that method. It holds true for variables as well as method. Now I'll do a set age of 300. 300 is an invalid value, right? But what happens is within this set age, I'm checking if that value is greater than or equal to 0 and less than 100. Only then I'm setting the value. Otherwise, I'm going to set it as invalid age. So given that this check is done before we do the assignment, whenever someone from any other class is trying to set an invalid value, as we have done now, it will set it's an invalid age 300. So it will not allow you to set the age which is not correct. So if you do a system.out.println and you try to get the age, right? So there is a get age method. I'll do a s1.getAge and I'll print the value that is there. If you see, it will have the initial default value that we had set, which is 50. That's the value which gets printed, right? In the constructor, if you see parameterized constructor, we set the age as 50. That's the value that gets set. So if you set the value as 100, it will accept that and it will take the value as 100, right? So that will get accepted and it will get printed. So this is the biggest advantage of the setter method. So setter method helps you to prevent setting invalid values. So whenever you define something as private, only within that particular class it is accessible. So the same thing, if at all we had, instead of using private, I had used it as public, the entire story will be wrong, because you will be able to change the value in the main method. So private helps you stop that. That means the access will be given only to the methods within that class. Now let's look at getter method. Getter method returns a value. So I am saying public int get age, right? So whether you want to read or write values, whether you want to set the value or you want to get the value, either of these cases you can access it from other classes only to getter and setter methods. System will not allow you to use it through any other thing. The private is very important access modifier which helps limit the control, right? This is where the data protection is happening. It helps prevent it, and you are not allowing any other class to access or modify the value. So this is a feature which is available in Java, which is not available in C. In C you saw that the user can change the value to anything. But here, using the setAge function, there is a condition check that is being made before you assign the value to age. Only if it's a valid age, you are allowing the user to change it. If it is an invalid age, the user cannot modify that particular field. This is very important. This is called encapsulation. This is where the data protection gets enabled through this particular feature. So again, recapping, quick summary, in this class, you have encapsulation enabled here. So encapsulation is protecting the data and method from unauthorized access and modification. So it protects the data and methods. It will not allow other classes to access illegally or modify the value. This is what is a very critical feature which enables data protection. This is encapsulation. So when we talk about encapsulation, access modifier plays a very important role. As we saw, private, if it is private, only the class can access that variable or method. When you say public, it can be accessed by every class. It can be modified by every class. Protected, we'll talk about it when we come to inheritance. By default, default means you have not set anything, right? You have not mentioned whether it is private or public. You have just set int age. In that case, it's called as a default. If it is default, it can be accessed within the package. That means all the classes within a particular package, Java package, can access it. Any other class which is outside the package cannot access it. So we'll talk about access modifiers a bit when we talk about inheritance.